You can tell what wearing a hat does to my hair. I spent all morning just puffing it up. Hi, good morning. Just a quick reminder, Thursday, start of the hour will be test number 2. It's, I've already talked about it. It's point breakdown, other information. It's located on Blackboard, and you also got an email. I'm going to do the review right now. Quick caveat, since last time I checked, I don't walk on water unless it's frozen. So I'm parking lot. But anyways, if I talked about something at least twice in lecture, it's fair game on the testing. If I forget to talk about it in review, I usually don't, but things happen. All right, let's get going. First functional group, alcohol. Hydroxyl group on carbon. How do you name it? Find the longest chain with the carbon with the hydroxyl group. Name it as an alkane. You drop the E, add OL. Now for acyclic, needing a straight chain, alcohols, you need a number. Which carbon has the hydroxyl group? Remember, always start from the end of the chain, and the hydroxyl group carbon gets lowest number, highest priority. For cyclic, no number, because the carbon with the hydroxyl group is carbon number 1. Common names for alcohols. You name R as an alkyl group. You name R as an alkyl group, and they add the word alcohol at the end. That's common names. There's one alcohol that the common name is the IUPAC name. When you have a hydroxyl group on a benzene ring, that's called phenol. How do you make an alcohol? It's one of the few reactions from test, like the only one from test 1 that will be on test 2 or could be on. You take a double bond reactor with acid and water. Remember, water is H and OH. You break the pi bond. One carbon gets the hydrogen, the other gets the hydroxyl group from water. And how do you know which? Follows Markov-Nichols rule. The carbon of the hydroxyl group, carbon of the double bond with the most hydrogen gets the hydrogen, the other one gets the hydroxyl group. What's today's date? 14. The helps me when I'm doing the videotapes. By the way, I will try and pretty much will guarantee by 6 p.m. tonight, it will take an hour. The video for today and yesterday's lecture will be online in case you want to miss the replay. So, anyway, and that's how you make alcohols. What are reactions to alcohols? The first one, if you take an alcohol that has a carbon adjacent to the carbon with the hydroxyl group with the hydrogen, heat it up with sulfuric acid. Sometimes I'll put the temperature like 180, but you don't need to see the temperature. What happens is dehydration, you lose the water to form a double bond. And where is that double bond? The follows Zayson's rule, which you get the double bond that has the most, and listen carefully, carbon atoms bonded to the carbon atoms of the double bond. Not total, just carbon atoms. If you go back and look at the practice problems, we've went through those. Also, this is a reaction you did with your own hands in the lab. Remember that stinky one you did with the sulfuric acid? Made cyclohexane. Take an alcohol, and react it with hydrohalogen acid, H, where X is chlorine, bromine, or iodine. You replace the hydroxyl group with the halogen. Unfortunately, if you had a double bond in the molecule, which I won't put on the test, this would react with that. So someone came up and figured out if I take an alcohol and react it with thionyl chloride, SaCl2, I'll replace the hydroxyl group with chlorine, but this will not attack double bonds. You take a primary alcohol, that's one where you have an R group on a carbon with a hydroxyl group, only one R group. I'll never ask on tests what's primary, secondary, tertiary. And if you oxidize it, remove a hydrogen here, hydrogen there, and you form an aldehyde. Take a secondary alcohol and oxidize it. Same thing happens. Secondary two R groups on the carbon with the hydroxyl group. They can be the same or different. Use hydrogen there, and you form a ketone. Again, the carbon, oxygen, double bond. I talked about polyols. And poly means many, OL means alcohols, as you know that's the ending. And those are molecules with more than one hydroxyl group. You don't have to know the name of it, but talks about this polyol that is ethylene glycol. You mix that with water, and that's antifreeze. So if I ever ask you an example of an alcohol you could use in your daily life, this would be one. And the product is it. Anybody happen to go by a gas station and think the gasoline has ethanol, which is an alcohol? I got one take. Oh, this is a rough crew. Well, it's a snowstorm Tuesday. Actually, the sun's out. And we lucked out. Oh, unfortunately, people on the East Coast, they're talking feet of snow, not inches. Hopefully things go well for them. All right, important thing. I talked about antioxidants, DHT, DHA. That will not be on the test. Next, I talked about if you replace the oxygen and the alcohol with a sulfur, we call that a thiol. An important thing you should know about a thiol. They stink. skunk's defensive weapon is essentially thiols and water. Onions and garlic have thiols in it. I don't think of onions and garlic as stinky, but they have a strong odor. And the last thing I did think you should know about is talked about that tragedy in Texas due to natural gas leak where a lot of people died in the gymnasium that blew up. And the bottom line from that was today we're safer because natural gas methane, which is odorless, contains a thiol, butylthiol. So when it leaks, you can smell it. By the way, propane has a different thiol, but same reason. So if your barbecue tank is leaking, you can smell it too if you didn't turn it off. That's all I asked you to learn about thiols. You take an oxygen and bond it to 2 carbon groups, we have an ether. I only asked you to learn the common names for ethers. Common names, name each R group as an alkyl group, and then add the word ether at the end. Diethyl ether is probably one of the most famous, and it was originally used as an inhalation anesthetic, and to this day, different ethers are used as inhalation anesthetics in the operating room. How do you make an ether? Williamson ether synthesis. You take an alkoxide, which I haven't asked you to learn the name, but that's an R group on a negative oxygen, sodium cation, could be other cations, but I would see sodium, it's cheapest to make. And you react with an alpha halide, remember X is a halogen, chlorine, bromine, or iodine. And this oxygen attacks and bonds to the carbon in R prime that has the halogen. You also get back a sub. I'll get it away so you can write it down. Actually, I talked about epoxides, but I only talked about one, and that's ethylene oxide, which you do not have to know the name, but since I used it, I'll write it on the board. And that's a common name. And when I did this, I was good, because I didn't drop into slang talk, since I worked with this area, which would be EO, but ethylene oxide. And I asked you to learn 2 reactions. First reaction is with an alcohol, plus ethylene oxide. And you get this ether alcohol. And I showed you some applications where that's used as a dispersant for oil that causes a lot of problems in the Gulf of Mexico. It's also used as a cleaning product in oven oil, the cold version, not the hot one. take an alcohol, react it now with N moles of ethylene oxide. What you get is a polyether alcohol, where the repeating unit O, CH2 is repeated N times, and the N comes from the coefficient of how many moles of ethylene oxide you react. Everybody listen up, common mistake. People put the hydroxyl group inside the bracket. That's wrong. Ooh. Time out for a public service announcement for me, the management. For test number 2, remember, how many bonds to carbon? 4. When you write an answer down, check, especially where you're changing something. You have 5 bonds to carbon or 6, it's going to be wrong. If you have 2 or 3, it's going to be wrong. The other thing is, do you break carbon-carbon single bonds? No, so check that too. That will be your friend. Next, I really got to have some fun, because I got to talk about one of my favorite areas, aldehydes and ketones. When you have a carbon double bond to oxygen, hydrogen and carbons on this carbon double bond to oxygen, we call this an aldehyde. When you have a carbon double bond to oxygen, now you have 2 R groups. That can be the same or different, R and R prime, R prime, R double prime. We call this a ketone. They both have something in common. Carbon, double bond to oxygen. Carbon, double bond to oxygen. That's so important now, I'm very biased about this, that a carbon double bond to oxygen in many functional groups is called the carbonyl group. And you should know how to draw a carbonyl group, and you should know how to describe it with words. And it's a carbon or carbon atom double bonded to oxygen or oxygen atom. Either way, you should know that. I don't know of anything more important to me personally in organic chemistry than that. But again, I'm quite biased. All right, I use that nomenclature, aldehydes. Find the longest chain that includes the carbonyl carbon. Name it as an alkane. Drop the E at the end. Add Al. No number, because the carbonyl carbon is always number 1. Remember on this test, alcohols are OL ending, aldehydes AL ending. Be careful how you write each, because if I have to guess, I have a 50-50 chance of guessing wrong. So make sure I don't have to guess, please. You cannot have an aldehyde in a ring, so let's move on to ketones. Before ketones, there's one aldehyde that the common name became the IUPAC name. That's when R is a benzene ring, and this is called benzaldehyde, which you all smelled in the lab, and that had the cherry or almond smell to it. I can smell both. And that's benzaldehyde. Let's continue on with ketones. Ketone, carbonyl, carbon double bond to oxygen with 2 R groups. How do you name it? You find the longest chain or ring with the carbonyl carbon, naming it as an alkane or cycloalkane. Quick other important public service announcement from the management, me. On the test, if you see a ring, don't forget to put cyclo. People like cyclohexane or cyclohexanone, they forget the cyclo. Don't. All right, ketone. Find the longest chain of ring, name it as an alkane or cycloalkane. Drop the E at the end. Replace it with ONE for acyclic. You need a number. Which carbon has the carbon double bond to oxygen to carbonyl carbon? It always gets the lowest number. Remember, always number from the end of the chain. If it's cyclic, no number. Common names, I've only asked you to learn 2. When R in an aldehyde is hydrogen, and this molecule reacts like other aldehydes, it's called formaldehyde. That's the common name. Nobody uses the IUPAC name methanal. It's called formaldehyde. And I talked about the dangers and the good things of formaldehyde in the lecture. The simplest ketone, when R and R prime are methyls, is called acetone. Nobody ever calls this 2-propanone. The IUPAC name is called acetone. And as you know, it's good for cleaning glassware in the lab, but more importantly, it's nail polish remover, one of the 2 types of molecules. Later on, I'll teach you the other type of molecule that can be used for removing nail polish. How do you make a ketone or an aldehyde? It's going to seem like deja vu all over again. You take a primary alcohol and oxidize it, and you lose hydrogen here, hydrogen there, form a carbon-oxygen double bond, and you form an aldehyde. Take a secondary alcohol and oxidize it. Again, lose hydrogen from the hydroxyl group, hydrogen from the carbons attached to, form a carbon-oxygen double bond, you make a ketone. Water break so you can catch up. Later in the semester, we'll learn how much organic chemistry goes into ketchup and mustard and other things. All right, special type of ketone. Take a benzene molecule, that's aromatic ring, but we'll just stick to benzene. Reactant is called an acid chloride, which unfortunately I do not have time this semester to talk about acid chlorides. They are quite interesting molecules. And if you use a catalyst, aluminum trichloride, this is electrophilic attack, puts on an acyl group on the benzene ring, replace one hydrogen, and this makes an aromatic ketones, and these play an important role in many things, including the sunscreen and suntan lotions you use, because this is a UV absorber, and it protects your skin from ultraviolet light and cancer and other bad things that could happen. Maybe cancer, I believe, but then now I'm way out of my league. Many reactions, aldehydes and ketones react the same way. And if R prime is a hydrogen, it's an aldehyde. If R prime is carbons, it's a ketone. If you react an aldehyde and ketone with one molecule of an alcohol and acid catalyst, what you'll get is a hemiacetal or hemiketal. Remember, in ketones and aldehydes, all the fun stuff happens at the carbonyl carbon, where the carbon is double bonded to oxygen, or some other stuff right next door. You take an aldehyde ketone, now react it with two molecules of an alcohol with acid catalyst. And a catalyst is something that makes the reaction go quicker and is not consumed. Keep your eye on the carbonyl carbon. What's ever bonded to that, just like in the first one, is still bonded to it. And now it will have two oxygens, and each oxygen will have the R group from the alcohol. And when the R prime is H, it's an acetal. When it's carbon, it's a ketal, which I won't ask you to learn, but other classes may talk about that terminology. What can you do with these molecules? You take a hemiacetal or a hemiketal and react it with acid and water. What happens? You get back the aldehyde and ketone you would have used to make that hemiacetal. Remember, what's ever attached to carbonyl, or in that case carbonyl, with two oxygens stays there. We take a an acetal or ketal, and react it with acid and water. Again, what do? You get back the aldehyde or ketone and the alcohol you would have used to make that. Keep your eye on the carbon. What's different? Always look for what's different. Two oxygens on the same carbon, that's rare, different. That gets you back to this carbonyl, either a ketone or an aldehyde, plus the alcohol you would have used to make that. For those who must, put a 2 there, I don't, because we don't balance equations unless we have to. These 4 reactions we'll come back to, because Mother Nature uses them extensively, A, to make carbohydrates, and B, in your stomach to have you digest them. Next, let's talk about one of my heroes in organic chemistry, Victor Grignard. And Victor Grignard won the Nobel Prize for discovering the following. First, if you take an alkyl halide, where X is chlorine, bromine, or iodine, react it with magnesium. You do this in a solvent like ether, diethyl ether, other ethers, you'll make the Grignard reagent. Time again for another important tip from the management. Remember, Grignard, R, bonded to carbon, bond to magnesium, bonded to the halogen. You put the halogen first, magnesium second, I'll mark it wrong. There's nothing like that, it's just in nature or anywhere else that I know of. Once you have a Grignard, what can you do with it? Something very special, very rare. You can make a carbon-carbon single bond. Take a ketone or aldehyde, react it with a Grignard reagent, second step, acid and water. The Grignard will attack the carbonyl carbon and bond to it and open it up to an alcohol, and you get the following. Whatever was attached to the carbonyl carbon is still attached to the carbon now with the hydroxyl group. This Grignard bonds to that carbon to form a carbon-carbon single bond. The carbon in R triple prime that this is on is the carbon that this carbon will be bonded to in R triple prime. Carbonyl group, the double bond is one pi bond, one sigma bond, just like a carbon-carbon double bond, but it's different, it's polarized, but still a pi bond. Therefore, take a ketone or aldehyde, react it with hydrogen and a catalyst, you break the pi bond, and each atom of the double bond gets a hydrogen. And you make an alcohol. Remember what was ever attached to the carbonyl carbon, our prime or H and our double prime are still attached. Unfortunately, you know that will also react with a double bond, and if you don't want to lose that double bond, what do? You use the invention of the great organic chemist H.C. Brown from Purdue, won a Nobel Prize for this. Again, if you take a ketone or aldehyde and react it with now a special new reagent, lithium aluminum hydride, second step, acid and water. This will only react with carbonyl compounds, not double bonds, but does the same thing as hydrogenation by breaking the pi bond, and each atom of the double bond gets a hydrogen. The nice thing about it is it's selective. It will only react with carbonyls, not double bonds. Not that I put that on my test, but that's the reason why that's important. And I've used both hydrogenation with lithium aluminum hydride and ketones and aldehydes. All right, as I mentioned, I have in the slides that I forgot to take out an oxidation of an aldehyde to carboxylic acid. That will not be on test number 2. That will be on test number 3. Next, I talked about an extremely important area to me, and that is the carbon bonded to the carbonyl carbon. The alpha carbon. The hydrogens on the alpha carbon are acidic. You can take them off with a base. And one base, sodium hydroxide and water. In a couple of weeks, you'll be doing what's called an aldol condensation. And you pull off a hydrogen here and form the enolate anion, negative charge on carbon. The enolate anion is a nucleophile. The carbonyl carbon is slightly positive. The oxygen is slightly negative. This says, ooh, enolate. I'm going to bond to you. And it opens us up to an alcohol. Whatever was attached to that carbonyl is still attached. And you form an aldol condensation product condensing two things together. And this is a special reaction because it allows you to, once again, do something very rare and elegant, and that is make a carbon-carbon single bond. By the way, organic chemists, when they do reactions or come up with new things, other people do use terms like, oh, is that beautiful or is that elegant? And they are. Any questions on aldehydes or ketones? Going once. Going twice. What are we doing time-wise? Wow. Well, in that case, let's have some fun. Let's have some fun. I'm going to share, because I haven't this whole time we've been together this morning. Give the organic product or products to the following. And for those who came in late, by sometime late this afternoon, this lecture and yesterday's lecture, this review will be on YouTube. So if you need an instant replay, it's there for you. Another Dr. White production. Paper, so let me help you out a little. And now I'll give you another 22.6 seconds. Go. Point one, point two, time's up. All right, let's take a look at this. What's different? Carbon, double bond to oxygen. It's got carbons here, carbons here. It's a ketone. Could have been an aldehyde. I'll call this R prime, this R double prime. You can have them reversed, doesn't matter. Ooh. Carbon with the magnesium, then a halogen, Grignard. Second step, Aspen water. What happens? Keep your eye on the carbonyl carbon. You break the pi bond, the R triple prime goes to the bonds to that carbon, this opens up to an alcohol. What I like to do is say, if this is the main carbon, which becomes this, I'll draw it first. What's ever attached to it is still attached to it. R prime, methyl, R double prime, methyl. I have an alcohol. Then my R group, R triple prime, what is that? Well, in this case, methyl. And you've now made that alcohol, and that's how you do it. What would be the starting material for this one, and today I'll help you out.
Thank you.
Time's up. What's different? Magnesium chloride on the carbon, Grignard. What's my R group? This. What do we have? My R group. Which carbon is the magnesium chloride on? The center one. So that means my halogen chlorine will be here. And that's how you do that. I'll help you out. I won't do this on the test, but I'll do it today. What's the organic product or products that are following? Hopefully by Thursday morning you'll know your general reactions. So everybody's done. Let's take a look at this. First question is, what's different? Oxygen. Double bond to carbon. Carbon's here and here. Ketone. Ooh. Number two, What do I have that's different? Carbon hydroxide group, 2 alcohols, acid catalyst. What do you get? A acetal, or in this case, ketal. What does this tell you? What's ever bonded to this carbonyl is still bonded. So I'm still going to have my ring. And this is a carbon. You don't have to draw it in, but I will, so you see where I'm looking at. That becomes from this carbon to this carbon. So it's going to have 2 oxygens. What's on that oxygen? The R group. And where do I get that R group? From the alcohol. Both of them are the same, which are ethyl. And why don't you try this one? And go back and look at the review and you'll see the general reaction. All right, let me help you out, and then let's do this. What's different? Oxygen. Oxygen, same carbon. That's different. Each oxygen has carbons on it. That carbon has carbons too. This could have been an hydrogen here. This is an acetal, acid, water. You get back the aldehyde or ketone you would have used to make that, the reaction down at the end of the board there, plus the alcohol. And those 2 must, you put 2 there that you would have used to make this. Therefore, what's R prime? Methyl. What's R double prime? Methyl. What's R and R? Methyl. I made it easy. And therefore, if we come over here, and we look at this carbon becomes this carbon. What's attached to it? Our prime and our double prime, methyl groups. Next, what alcohol we get? Here we have the R prime, R group, and that's also methyl. And that's the product you get. With that, remember, practice. You got time, learn your general reactions. For those of you who learned the method, practice that too. And with that, I'll see those who have lab at 11 o'clock. Please be prompt. Those of you who don't, I'll see you tomorrow. For those who are leaving now, drive carefully. It's getting icy out there. For those who are leaving later, drive carefully.